Okay, here we go. 3.3. I believe we're going to be doing properties of logs. So what happens when you only have a scientific calculator and it only has the buttons for log base 10, which you would just see as a log button, and it's got the natural log button, which you'd see as an ln. But yet you're given a problem that says find the log base 5 of 18. If you had a Inspire, you could go ahead and change the base, and you could do this without any problem. But if you have a scientific calculator, you're going to have to rely on the change of base formula. And without giving you the formula straight up, I'm just going to show you how to do it. Since we only have the log button and the natural log button available to us, we're going to use one or the other. This time we'll use the log, and we're going to put it both in the numerator and the denominator. Then we're going to notice that our base for the log is 5, so we're going to put our base in the basement. And then we're going to put our 18 in the numerator. However you decide to remember it, if you want to use the base in the basement, basically, if we want to know what log base 5 of 18 is, we can find out by using log of 18 and divide that by log of 5. So when you put that into your calculator, you get approximately 1.79. So with this next one, we don't have a log base 2 button on our scientific calculator. And so instead of log, let's use the natural log button. We can use that as well. So we'll put natural log in the numerator, natural log in the denominator. The base of the log goes into the basement of the fraction, and then the other number goes here. So we are saying that log base 2 of 42 is the same thing as natural log of 42 divided by natural log of 2. And if you put it into your calculator, you would get approximately 5.39. If you would have done log of 42 divided by log of 2, you would have gotten the same answer. So on your note sheet, which the note sheet is, you either have it in your possession or it is on the blog right under this video, go ahead and write that you can use either the log button on your calculator or the natural log button on your calculator. So it's a nice little trick. If you were in class, we would do marker boards and we would have fun. And then we're going to go back to notes. Properties of logs. So there's a lot of rules that we see here. And instead of going through the rules, we're going to go ahead and apply them. I think that's how we learn rules best. Just like in our exponents, if we had something like x to the 5th times x squared, what would we do with our exponents? We would add them, right? That x to the 5th times x squared is x to the 7th. So with exponents, multiplication and division are linked. They're related. Same thing with logs. If we have a log of something times something, we can rewrite that log this way. So let's look at our example 2a. Natural log, which of course is a log base e. We're doing natural log of 5 times e to the 6th. So we can split that up. Since 5 times, I know we don't really see that multiplication, but it's really there. That's the same thing as writing natural log of 5 plus natural log of e to the 6th. So that's our first rule that we look at. We know that just like exponents have multiplication and addition connected to each other, so do logs in that rule. The second rule that we're going to use here is the power rule. And the power rule says something special happens when we have a power here. It ends up going there. So you can see that over here. And so natural log of 5, we can't do anything else to, but we're going to go ahead and pull that 6 down and get natural log of e. Now, I know what you're thinking. There's a couple things you could be thinking. One, Miss Overby, we already knew natural log of e to the 6th power was 6. Why do we have to do this? And I'm saying, yep, you're right. But I'm showing you another way to do it by using the properties of logs, and we're still going to get the same answer, right? Because natural log of e is 1. 1 times 6 is 6. And then you're going to put that in your calculator, natural log of 5 plus 6, and you're going to get approximately 7.6. The other thing that you might say to me, something that one of my second block students noticed. They're like, Ms. Overby, we could have just put this original problem in the calculator and got the same thing. True, very true. But we're using this, the way we did it, we are practicing our properties. And you can even test that. Put that natural log of 5e to the 6th in your calculator and see if you do get the same answer. Same thing here, right? We could just go ahead and put, we don't see parentheses, by the way. We could put parentheses here, but I want you to note the natural log applies to the fraction 6 over e squared, not just to the 6. Okay, so here we go. We could put this in the calculator. We could also use this time to practice. This is called ratio. I think sometimes you see it as quotient. But basically, we remember with exponents, if we had x to the 5th divided by x squared, we know our answer would be x cubed because 5 minus 2 is 3. So we know with exponents, division and subtraction goes together. So it would make sense that with logs, division and subtraction is going to go together as well. So when we see the division, we can rewrite this in a different way. This is the same thing as saying natural log of 6 minus natural log of e squared. And yes, we're very aware that natural log of e squared is just 2. But once again, just humor me. Let's go ahead and pull that 2 down. And that's just another way to see, oh yeah, so 2 times natural log of e is 2. So we'll get natural log of 6 minus 2. You're going to put that in your calculator, and you're going to get 5. Let's see, nope, this is example 2. You're going to get negative 2.1. All right, so we're using properties to see how we have different ways to solve something. And I'm checking on the time. I'm going to try to make this as quickly as possible. All right, so we would, if you were in class, we'd do marker boards. And I think one of the things, nope, we're not, okay. Now we're going to use the properties to do something really important, and that is to expand our expression. And I know what you're thinking. Well, I don't really know what you're thinking, but you might be thinking, Ms. Overby, this is a nice log. It's all simplified. Why are we going to expand it? And like I told students in class, is that when we get to calculus and we're taking the derivative of a log, it helps us if we expand it first, so we can take the derivative. Sometimes we have to expand to take the derivative. So here we go, we're getting ready for calculus. I see a lot of little multiplications, right? So we're going to break that up, and we know that's the same thing as log 2 plus log x cubed plus log y to the 4th. And then the second rule that we can use is the one where the power gets to come down. We don't do anything with log 2, but we can bring the power down and the power down. We could probably take it one more step if we wanted to and pick up our calculator and find what log 2 is. But we're not going to do that because we're just really practicing the properties and how that helps us to expand. All right, this is a fun one. In this one, we see that we have division. Once again, this natural log goes to the fraction, not just to the numerator, right? To the whole fraction. And so that's the same thing as writing natural log of square root of x plus 5 minus natural log of y squared. We're going to stop and do a rewrite. It's not using a property, it's just rewriting, so we can use a property. That square root, just like we talked about in class, we want to write that as a power, as an exponent. So we know that the exponent 1/2 is the same thing as the square root. And right, that was necessary to rewrite it, so then we could pull the power down. So once again, remember that 1/2, the power 1/2 is the same thing as square root. And so we're going to pull the 1/2 down and the 2 down. And can we expand it any more than this? Can we make it any wider than this? No, we are done. I wanted to stop. I know that on your note sheet, you stop with the B, but I wanted to also do one of the ones that we have for marker board. So this looks a little different. So pause the video just to write this down real quickly as a C. Go ahead and put it on your notes right next to B. You've got the space. And here we go. So we know that, first of all, we've got that square root. We've got to do a rewrite even before we begin. So we're going to go ahead and rewrite that with a 1/2. We cannot split up the division into subtraction until we get rid of the power. So we're going to bring the power down. Oops. And then we're going to keep in mind that the 1/2 goes towards the whole thing. We're going to have natural log of x minus 3 minus the natural log of y to the 4th. Do we have anything else we can do? We sure do. We can pull down the 4. And if we wanted to, we could distribute that 1/2, right? I know when I was in class, one of my students suggested doing it a different way, and it actually took less steps. So I'll start it. I'm not going to finish it. If you wanted to do it a different way, you could rewrite this as natural log of the square root of x minus 3 over the square root of y to the 4th. And actually, why not finish it? It's fast. It's pretty fast. So we're going to rewrite it. We'll have natural log of square root x minus 3 minus natural log of square root of y to the 4th. We'll do a rewrite. We'll notice, hey, square root of y to the 4th, well, that's y squared. We'll bring down the 1/2. And we'll bring down the 2. That's actually a really good way to do it. It's faster than my way. And it's the same. Note that these are the same two answers. If you factor out a negative, or I'm sorry, if you factor out a 1/2, you're going to get the same thing as mine. If I distribute the 1/2, I'll get the same thing as the problem in the blue. That's the beautiful thing about math, right? Well, one of the beautiful things about math. You can do a lot of problems different ways depending on how your brain decides to approach it. So if we can contract something, if we can expand something, then we can also contract it, right? So contract, to me, contraction's the opposite of expansion, but a lot of books call it condensing, so we can call it either way. So here we've got a nice long log statement that is just, or log expression that's just ready to take the derivative of if we were in calculus. But now let's say we want to go ahead and condense it because we want it to look smaller. And so let's go ahead and bring that 2 up. We're going to do the powers backwards. Instead of bringing the 2 down, we're going to pull it back up. And let's see, we're going to go ahead, we're going to leave that minus sign there. And we're going to pull the 3 back up. And we're going to go ahead and pull the 1/2 up. And now we're going to read this log problem from left to right. And I notice this right here can be rewritten like this. We're going to bring down that. And then we can rewrite this as, since we have a plus, this is saying x squared over y cubed times z to the 1/2. So if I'm going to multiply that, this is what it's going to look like. I'm going to also switch that to square root. Hopefully you don't mind that. And we're done. Now, we talked about, at least we did in 4th block, we talked about doing these problems intuitively. Some people can look at this, see that we have a log with each one. We know that when we contract it, when we condense it, our answer is going to end up with just 1 log. And they can just tell intuitively who belongs on the top and who belongs on the bottom. This first one, they say, belongs on the top. And because this is a minus, that puts that one on the bottom. And because this is a plus, that puts this one on the top. If your mind thinks like that, go for it, because you'll get the answer correct. All right, so let's look at this next one. We've got a 1/3 out there. We're going to leave that 1/3 to the very, very end. So here we go. Let's see, we're going to pull the 2 up there to be in the power. We're going to pull the 4 up to be in the power. And we're going to leave the rest of it. There's nothing else to do. Here we go. Now, once again, if you want to do it intuitively, you can just know that there's only one natural log. If I'm going from expanding to condensing, I'm taking 3 natural logs into 1. Okay, I'm only writing 1. Who goes on the top, who goes on the bottom? Intuitively, I know x squared goes on the top, y to the 4th on the bottom, and z plus 2 on the bottom. Does that not make sense to you? If it doesn't, then we're going to do it the long way as well. So let's finish this out. Then the 1/3 would go to the top. And certainly, if I felt like writing this all out again, I could just, oh, why not? I could write it like this, right? I guess the point I really want to make is 2 points. One, math is usually pretty darn intuitive, and this is nothing different. It just makes sense to do it this way. And 2 is that when we are going from a stretched out, expanded log series, we want to go ahead and condense it. We are only writing 1 log, 1 natural log. All right, you want to see this the long way? Let's do it the long way. Although that seemed pretty long. All right, once again, we're going to do the same thing. I'm going to take it from this step. So this was our first step. We went ahead and pulled everything up to the powers. And so if I think about just going from the left to the right, then this tells me that I have natural log of x squared over y to the 4th minus natural log of z plus 2. Okay. When I look at that, I know that this is going to be divided by that. Okay. So that's going to mean that I've got the z plus 2 on the bottom. If I were multiplying it by the fraction x squared over y to the 4th, I'd end up with the z plus 2 on the top. But because I'm dividing, it's the same thing as saying multiply by 1 over z plus 2. And then, oops, my 3 ended up with being a 2. And then, of course, we're back to where we started from to this stage, and we're going to continue the same way. I hope that I didn't make that more complicated than it needed to be, because it didn't need to be complicated. All right. We've got marker boards, we're contracting, we're condensing, and you have a book assignment. I did that because WebAssign might be a nightmare to try to get these long, complicated answers in. So please do your book assignment, check your answers. They're all odd questions, and remember that practice makes permanence. Okay, see you in class. Thanks for joining me.